Hey everybody, this is DLL Cool J coming at you from ArchCloud Labs, and today we're going to do something a little different. We're going to quickly deploy a single node Kubernetes cluster with Canonical's Microk8s. So if you have any Ubuntu VM laying around and you are okay with using snap packages, it's super easy to quickly deploy a single node Microk8s cluster and then start messing around with Kubernetes and deploying some Kubernetes workloads, as well as exploring some other add-ons such as Helm or Istio, etc. We're going to take a look at all that in a quick second here. But if you are new to Kubernetes and you're looking for an easy way to really focus on, hey, like how do I create workloads, deploy, Microk8s is a really good option just to kind of get you out of the box and quickly focusing on the workloads you're interested in versus like, okay, do I do it in a cloud provider? Do I do it locally? Do I want to spin up a bunch of VMs and whatnot? So there's a lot of different ways to deploy Kubernetes. There's no inherently wrong way. It just really depends on what you're trying to accomplish. So I often find that, to kind of get your hands dirty and shorten that time of getting rapid feedback when learning a new thing, it's really important to just kind of dive in. So that's why I chose to kind of talk about Microk8s. That being said, there's a bunch of other Kubernetes distributions as well. Minikube is another really popular one, which can use a multitude of different backend providers. So by default, I believe it'll use Docker to stand up the core API services that Kubernetes requires to provide all of the orchestration that Kubernetes can do. But you can also say, hey, I want the backend to be KVM. So you can have dedicated virtual machines getting deployed, and I also think that you can actually get Podman backends as well. Regardless, we're going to talk about Microk8s today, and you can definitely feel free to explore the Canonical webpage of Microk8s.io, and it kind of just goes over what exactly Microk8s is. One thing to note here is that Microk8s is intend to be an enterprise option. So if you're looking at doing some IoT-based things or something that you don't require some kind of crazy cloud provider, it's worth kind of like a start to start playing around with. Depending on what your workloads look like, everything's going to vary. So definitely explore all the options that are out there because there are quite a few. So that being said, I'm going to go ahead and kind of jump over to the Vagrant file that I have here. So what I have going on, and I let this run in the background, is I have a Vagrant file that will spin up a Ubuntu 2004 virtual machine, backend being KVM if you're interested, and provision the host with a handful of commands that we need to actually update the machine and then install Microk8s via snap. I went ahead and prepended the time command just to see how long this would take. You can see here, just a little over a minute, not too bad. And if we go ahead and take a look at the Vagrant file, just to kind of reveal what this looks like, it's nothing fancy. It's easy to throw a bunch of basic commands into one of the shell provisioners and have that provision on the back end. If you're unfamiliar with Vagrant, effectively it is a way to quickly spin up and provision a bunch of different virtual machines. In this case, I am specifying, hey, I want my box to be a generic Ubuntu 2004 virtual machine, along with using the libvirt backend. However, here, if you're using VirtualBox, that's where you would specify VirtualBox, as well as any other configuration options for the VM itself. So here we have 2 gigs of RAM. I can go forth and specify different storage settings and CPU settings, IP addresses, etc. But for right now, I'm just specifying 2 gigs of RAM and accepting the defaults along the way. Down here we have a shell inline provisioner, so here it's actually just going to go through and execute all of these as kind of like shell one-liners. You can change this to be a magnitude of different provisioners. Definitely check out Vagrant's documentation to see that. But once that's done, I can go ahead and just do Vagrant SSH, and now I am in my Ubuntu 2004 virtual machine. And now I can go ahead, type Microk8s, kubectl, get pods, -A for all namespaces because there's not going to be anything running in the default namespace. And here we see in the kube system namespace we have some Calico pods running as we may think. Excellent. So let's go ahead and get the status of the nodes, because it's always important to make sure that the nodes are in the ready status so they can actually accept and run workloads. If you just spun this up, it might take a second and it'll say not ready. You can just wait a couple more minutes or append the -w command to kind of just wait, and this will refresh every so often until the node status has changed to ready. So at this point, fantastic, we have a single node Kubernetes cluster that's ready to receive workloads. Cool. It's been like 5 minutes and we've already got a ready to go cluster of one. So let's go ahead and deploy a very simple Nginx pod and then interact with it. So to do that, I'm going to go ahead and do Microk8s kubectl run. I'm going to call the pod Nginx. I'm going to specify an image of Nginx, and then I'm just going to go ahead and execute it. And here we see we have pod Nginx created. Let's go ahead and get those pods, and excuse me as I mistype here. And we see, and I don't need the -A because that's getting for all namespaces, we see we do in fact have the Nginx pod running. That's great. By default, Nginx will serve up a default almost hello world-esque web page. Let's go ahead and get the IP of this pod so we can interact with it. So the nice thing about this also, when you start talking about like a developer-focused distribution of Kubernetes, so you can just kind of quickly get up and running and poking at things, is that we're all on the single node. I can route to this IP address, so I can go ahead and actually curl this right from this node 78.194, and because I'm sitting on port 80 by default with an Nginx service, I don't need to change anything here. And sure enough, I get a lovely Nginx page back. Excellent. So a couple of things off the bat. We spun up a cluster in just a handful of minutes, deployed a pod, and we were able to interact with the pod, proving that it's working, kind of like a smoke test, if you will, to make sure everything's good before we move on to our next steps. A couple of things I kind of want to do just to show other things to explore with Microk8s. If we go ahead and just type in Microk8s, we can see a bunch of additional subcommands. Helm being the package manager for Kubernetes to deploy more complex workloads. You can leverage that through Microk8s. Additionally, there are add-ons. These add-ons we can explore if we type in Microk8s status. So here we can see we have a handful of add-ons that are disabled right now, a couple of those being Helm. If you have a NVIDIA card on, say, a dedicated machine, you can enable the GPU add-on and then interact with your NVIDIA card that way through Kubernetes. I have done this on separate machines as just kind of like a hello world of NVIDIA CUDA. It was seamless and super easy to bootstrap and go. Additionally, you can set up a local image registry, set up Prometheus operators to grab monitoring logging data, and a handful of other things here as well. So let's go ahead and say we want to enable core DNS, for example. Let's go ahead and do Microk8s enable DNS. And bada bing, bada boom, we've gone ahead and enabled this add-on. We're restarting the kubelets, DNS is enabled, and we can check this in a minute. So now, again, to make sure that our pods are up and running, let's go ahead and do Microk8s kubectl get pods. Show me all the namespaces. This is going to be in kube system. And it shows that it's running over here at 19 seconds. Interesting enough that it doesn't appear to actually be 1 out of 1. There we go. Okay, now things make sense. Not sure why it said running, but then actually didn't show anything deployed over there. Let's assume that's something wrong on my end and just keep moving along. All right, so with that, I'm going to go ahead and then tear down this Vagrant machine, Vagrant destroy, and I will also post a link if you're curious and just want to poke at this Vagrant file to make it easy to set up and destroy a single node Kubernetes cluster. Thank you so much for watching. From my lab to yours, this is Arch Cloud Labs. Likes, comment, subscribe. Thanks a bunch.